Pixel Composer have a lot of nodes, so it can be a little bit difficult for you to start learning it from scratch. So in this video, I want to introduce you to a commonly used node in any project. So let's get started. The first group of nodes is a generator node. When you right click on the add node dialog here and the generator section, you're going to see a bunch of nodes that used to generate image. And these are, I think, one of the more commonly used one. We have the basic solid, just output a surface of solid color. Here we have a toggle to make it completely empty or completely transparent. And you can also set the color you want. Right, then we have the draw shape. This one is quite important. As the name suggests, it will draw a shape. Right, in the shape control here, you can select all type of shapes you want. You can control the transformation, the shape scale, the rotation. Right, and if you want to have more control over the positioning, you can change it into a bounding box to control where to draw your shapes. And there are multiple output for this node. We have the basic color output. So in the render setting here, you can change the color. And then we have the mask output. So it just can be black and white mask. And the height map output, which will output the height or distance from the current point to the nearest edges. Then we have the draw gradient. This one is also very useful. Just to draw gradient, right? You can select what type of gradient you want to draw. You can change the shifting. You can shift the gradient around. You can change the scale. And there are different shapes, different types of gradient you can select from. Then we have this noise generator. From the basic noise, just a hash noise. And we have the Perlin noise, which is basically just multiple scale of noise image overlay on top of each other. You can see in the iteration property here, you set it to 1. And maybe if you set the scale to be like really big, it will basically just be the same as the noise one, right? But as you increase the iteration properties, you overlay different scale of Perlin noise to add more detail to it. Sometimes when you use Perlin noise, you might start to see some patterns or some like rectangle shapes. It's just a quirk of scaling the noise like this. We also have simplex noise, which give it a little bit of a more various texture, more randomization, especially at lower iteration number. The disadvantage of simplex noise is that in Pixel Composer, you cannot do tiling for simplex noise. With Perlin noise, it will have tiling by default, but with simplex noise, it doesn't tile properly. You will need to have extra nodes for that. And then we have cellular noise. This will be a noise set based on like some concept of cell. So in the type property here, you can set different types. We have the point type, edge type, just play around with it. And then we have the property that control for the scaling, the transformation of the noise. You can also increase or change the iteration. Same concept here, just layering different scale of the noise. And then we have the pattern generator. So here in the generator section, you can see this pattern here. There are a number of patterns you can select from. Right, we have like the basic stripes. We have the checkerboard patterns. And then we have a different grid pattern. So if you right click and go to the pattern section here, you're going to see the different nodes related to grid. You have the basic grid, triangular grid, hexagonal grid. All of those nodes work similarly. You have control over the grid transformation. For the basic grid here, you can also shift it to create like a masonry pattern. You can give it random scale as well, so that each layer have different scale. There are different render type. For the tile color here, you can give it a random color so that each grid cell have different colors. Or you can change the render types. For example, you can have a texture grid, so now you can use another texture and then fill in each of the grid cell. Or you can use texture sample. So each of the grid cell here will sample from the original image. Maybe if I use gradient, you will see that each of the cell will have the same color, right? Sampling from another surface. Right, and those are the generator node. Right? Those are mostly where you start. Next will be a filter node. So in the add node menu here, you're gonna see the filter. It also have a number of nodes. We have the basic stuff like the blur node. Kind of obvious what it does. It just blur an input image. We have the basic outline. You can add outline inside or outside. We have the bevel. So different will bevel out to add in some dimension to your input image. Then we have the node related to like brightness modification. I think the common one we have the level, curve, and threshold. So we're going to use gradient as an input image here. In Pixel Composer, we will use 0 to 1 to indicate the level of brightness of the pixel. So in this case, the black here will be 0, right? And the white here will be 1. So first, let's take a look at the level node. The level node here will basically control the range of the darkest pixel in your image and the brightest pixel in your image. Like for example, like I said again, the original surface here, the black here is 0, the white here is 1. If I change the white in property to 0.5, what it does here is that the middle here 0.5 will be changed into the new 0. So we see in the property here, we say that 0.5 here will turn into 0 and 1 here will stay 1. So for the output image here, the 0.5 brightness in the middle will turn into 0 or pure black. And everything less than that will also be black. And then the 1 will stay 1. And it will just interpolate between that linearly. You can do the opposite if you set the minimum white to 0 and then the maximum white to 0.5. If you do the same thing, the 0 stays 0, now 0.5 will become 1, right? And everything higher than that will stay 1. Another use for this node is, for example, when you have maybe a noise like this, then you do some color modification to it, or you modify it, it become really faded. So the black color maybe doesn't go that black, or the white color doesn't go very white. You can put it in level, and you will see the histogram here. You will see that it will show the amount of pixel in different brightness level. Here it will say that the darkest pixel is not really dark, right? This will be 0, this will be 1. The darkest pixel will kind of stop here. the brightest pixel also just stop here, and you are missing a lot of information, missing a lot of brightness information here. You can even go to the histogram itself and then drag in the darkest black and the brightest white to be in this range. And as you can see, the output here will have more detail. The dark area here become darker, the bright area here become brighter. There's also an auto brightness option that will automatically do that for you. This process is sometimes called normalization. You normalize the range of your pixel to 0 to 1, and there are nodes for that that's just called normalize here. You plug it in, it's just gonna do the same thing, right? But this one is automatic. So it's just gonna find the brightest pixel, the darkest pixel, and then adjust the level to make sure that it go from 0 to 1. Now, I keep saying linearly for the level node because if you want the brightness to be controlled non-linearly, then you would need the curve node. To visualize how it works, I'm gonna bring in the cross-section node. It will basically just calculate the brightness of each pixel and then output it out to you, right? And this is a cross-section of our original image, right? So it goes from black to white, so it just go from 0 to 1. It's a linear line, right? When you plug it into level, you will see that the change in the brightness is always a linear line. But now with curve, you can remap the brightness of your pixel using a curve data. The default curve is just a linear line like this. If I plug it in, it will be exactly the same as our original surface, right? But now notice what happened when I try to change the brightness curve. Like this, you will see that the brightness of the pixel will adjust according to the curve. It looks almost like the same curve, right? This one and this one. So the change in brightness of each pixel will now be applied non-linearly. The x-axis here is the brightness level in, and the y-axis here is the brightness level out. And when you adjust curve like this, what happens is that at 0.5, so this is a middle gray, right? This is 0.5 out, but our actual curve is higher. So we push the middle gray to be brighter. And in this case, we will basically bump up the pixel to be brighter across the board. We can also do the opposite. Just push it down to create this sharp curve. And the output here, as you can see, the brightness ramp is getting slower at first and then going faster at the end there. You can even invert it. So now the black pixel will become white, right? At x0, y become 1. At x1, y become 0. So you basically invert the brightness. And finally, we have a threshold. And the threshold is basically like a switch. So if you select the threshold here, there was an option for brightness or alpha. If you select brightness, you will see that it will just convert your grayscale image into black and white using these threshold properties. And this is where it's gonna decide how bright it is to be black, how white it is to be white. And if you set it to 0.5, it's just gonna be in the middle. And as you adjust the range, the threshold here, you will see that the amount of black, the amount of white will be adjusted. You can also control the smoothness, right? You can have it invert. There's a built-in inversion there. And the threshold node here can be useful when you want to select some brightness level or you want to apply like some sharp contrast to your image. Like if I plug in maybe a simplex noise here into threshold and I reduce the smoothness, you will see that I will be able to select a different level of brightness from the image, right? And these are the nodes related to brightness modification. And lastly, in the filter section here, we have the Displace. This is a really important node that we use in visual effects. I'm not sure that I'm going to go through all the detail today, but the general idea is that you provide the original surface, in this case just a circle shapes, right? And then you give it the Displace map, which is a grayscale image. And what it does, let me reset it. And it will shift the pixel based on the brightness of the displacement mask. And in this case, in this linear case, it will move the pixel linearly. So I adjust the Y value here. You can see the pixel will move around in Y axis. And it can be extremely powerful when you add in more complex displacement map, like using maybe a simplex noise here. As you can see, I already give it some interesting complexity. There are multiple modes of displacement. This is a linear displacement. If you change it to different methods like vector, this one uses red and green channels to modify the X and Y axis independently. You also have the angles, similar concept but in polar coordinate. And we have a gradient when the pixel try to follow the gradient of the displacement maps. Then we have a node related to composition. From the basic transformation, we have the transform node and padding node. And as the name suggests, it's basically just useful for transforming. So moving, rotating, and scaling your image. And for padding, it's basically add more padding, so add more empty area around your original surface. Now, in the transform node, there are some extra properties that are not necessarily related to the transformation, but I add it because it's kind of useful. Like the opacity, right? Sometimes you want to add like an animation, fade in, fade out. Normally, you need to use the color adjust node, but the transform node itself also have the opacity control. Right, then we have the blend node. This is probably the most important node in any kind of software like this, right? It's a node that combines two surfaces into one using a different equation that we call the blend mode, right? If you go to blend mode here, there are a number of blend modes and it can be a little bit overwhelming at first. But I think the most important things to know, if there are two blend modes that you should care about, the normal blend mode is basically just drawing on top of each other. So I plug into surface, it's background and foreground, it will just draw on top. There are some like slight opacity blending, right? But it's kind of like what you would expect it from the basic blending, right? Another really important blend mode is the multiply, right? And the concept here is that every single pixel in an image inside Pixel Composer composed of 4 numbers. Well, normal surface at least. We have the RGBA, right? So the red, the green, the blue, and the alpha. And that number go from 0 to 1. And when you select multiply node, it will do exactly that. It will just multiply each of these channel to each other. With the white color like this, it basically is 111 in the RGB. And with the solid pixel, it will also have alpha of 1. When you hold control and mouse hover on the preview panel here, you're gonna see on top, you're gonna see on here, that is gonna show the hex value and the opacity at the end there. When you multiply everything with 1, it stays the same, right? And when you multiply everything with 0, it turns to 0. And that's precisely what happens here. When you multiply the color, I don't know what RGB it have, but you multiply with white, so which is 111, it's gonna stay the same, right? It's gonna be the same color, right? But this area here, it have alpha of 0. So when you multiply alpha with 0, it will become 0. So our output image here become transparent. So everything that is white here will stay the same being the same as the background, and everything that's transparent will just stay transparent. And that's the concept of multiply by node, right? And because the RGB value have the range of 0 to 1, if you have gray like this, like we already covered, this is 0.5, right? And when you multiply stuff with 0.5, it becomes less, it becomes half. So if you multiply the brown one here with the gradient like that, you will see that your image will become darker. If you want the opposite of that, there are another blend mode that are kind of the opposite of that. It's not division. You will think that the inverse of multiplication here will be division. There are division nodes here, but the output are different. The inverse of multiplication is screen. Instead of having it going from darker and darker, the screen blend node will basically make it brighter and brighter. You can check the tooltip here at the end of the blend mode. The tooltip here, if you click on it, it will actually show you all the equation for every blend mode. And you can see the equation from screen here. It actually multiplied with inverse value. So that's going to make your image brighter. Right? They also have addition. Addition here is just adding, right? So when you change to addition, you will see that it will also make it brighter. There's going to be like some difference in the level of brightness here. Then we have the preserve alpha. This one can be useful when you have two images like this. Right? I want to add brightness from this pixel to the circle here, right? But because it's an addition, it will also add RGB and the opacity as well. So the opacity is 0 here, but this one have opacity of 1. You add them together, the result is 1. You're gonna have all the opacity here. But if you don't want that, you want to have the same opacity as the background surface, you can go and click on preserve alpha. Then it's gonna preserve the alpha of the original background surface. Now, if you have more than 2 surfaces and you want to draw them and like have more control over the transformation, you need to use the composite node. Because the blend node only accepts 2 inputs, the background and the foreground, but the composite node can accept as many inputs as you want. So here, you can just plug in the input into it, plug in more surface, and in composite view, you can freely modify, move around every single surface. Then we have the hotkey for adding the blend node and the composite node. Because these 2 nodes is not that you're going to use a lot, there are hotkeys for that. You can select 2 nodes and you can press Ctrl B. It will create a blend node for you between the 2 surfaces automatically. Now when you're using the hotkey, you will see that the outline of the node is like yellow, right? It's not the normal orange. And on the bottom left area here, you will see that there are extra hotkeys that you can use. This is a core node chord, and this is a quick way for you to edit property on creation. Like in this case, I want to multiply it, I can just press M. So just press M, and it will multiply it for you. But if you click away from the node, it will disappear. Now, if you want to composite multiple images, you select all of them, and then you do Ctrl Shift B. You will just add all of them to the one composite node. Right, and these are though in the composite section. Now we're gonna go to the post-processing. Now I say post-processing, but like there's no post-processing section in here. This is mostly where you're gonna use it after you finish everything else. We have stuff like Colorize. So this is a node that will convert the grayscale image into color. So we can have the gradient here. Plug it in, and you can select the gradient to map it to, and it will just map the black and white here into a new gradient, right? So the black here go to the left, the white here go to the right. Let's plug in different surface to make it look nicer. There's some property that you can do. You can shift the gradient. Let me use like the 5. Then we have Posterize. This node is really useful with pixel art, right? Because you want to keep consistent palette. And this node will do just that. It will convert this like continuous gradient into a discrete color based on the palette you give it. Let me choose a different palette. And on the similar concept, there's also dithering, right? And the dithering is the similar concept, right? You convert continuous range of color into a more discrete, smaller set of color. Right? But with dithering, it's not gonna just keep this sharp edge, right? It's gonna try to create like more smooth transition between color. Yes, we can just use gradient for that. You can also adjust the contrast here, right? To reduce the size of the dithering, the banding. It will try to like create these hash patterns to reduce the contrast between each color, unlike the posterization. And there are different dithering patterns that you can choose, right? There are some of the default one, but you can also use custom surface as a dithering pattern as well. And this is something that I just discovered recently, is that if you add in the mesh pattern and then you plug it as a custom dithering surface, you can create some really interesting like patterns in your output as well. It looks kind of interesting, I think. And then we have a more pure post-processing stuff like chromatic aberration, right? We just give it like this chromatic aberration on the edges. And the vignette, which basically just darken the edge, right? Is replicating the effect of vignette from photography. One trick that I use quite a lot to make your image look a little bit like more pop is to just add in vignette with some really high exposure so that it doesn't eat away too much pixel. And then you plug it into Posterize, and immediately you make the image look more interesting. You add some type of details, some type of curveness into it, and maybe reduce the strength a little bit. With this kind of effect, you don't want to overuse it, but just a small detail already make your image look interesting. Lastly, we have two extra nodes, right? This node is very specifically for pixel art, and especially used for when you do some kind of image generation, and the image come out like noisy, or maybe looks wrong, look off. Most of the time, because it violates some of the pixel art principle. The first one is a corner. This is what happens when you have like a pixel corner, right? This is a pattern of like a 2x2 pixel that have the same color, or sometimes even 3 pixels that appear in triangle shapes, right? Right now, there are situations where you would want a corner. Like in this example, this grid patterns, you might want a corner this one because you want it to seem like a rectangle, right? Like a sharp edge. But in some situation, maybe we're trying to draw from the part, or when you do like a particle simulation, when the image was supposed to be a sharp edge, maybe like a circle, but it got rotated, it got scaled, and it have some corners show up. You can fix it using the decorner node. I'm still gonna use this image as an example. Plug it in, and it will just remove the corner of the corner in your image. Again, I'm not saying that there's anything wrong with this. This is actually how you want it to be. You want it to be square, right? But I just imagine that is other surface, other image that have these corner problems. You can plug it into the corner and it will just remove the corner for you. There are some properties at the iteration so that you can repeatedly remove the corner until non-visible, because sometimes when you remove the corner, you create a new one elsewhere. Another concept is the stray. So this one talk about the stray pixel, right? When you have like a stray pixel, right? Just one single pixel alone alongside other pixel. And having a stray pixel is not wrong, right? Especially if you have like dithering. Having a stray pixel is what dithering does, right? So having a stray is not a problem. It's having a stray when you're not intended to, right? And the distray node will do just that. You plug it in and it will just remove the stray pixel. Similarly, there are control over how strictnet it will detect the stray pixel. And we also have iteration. Similarly, you can also repeatedly remove stray until none exists. But so these nodes are really specific. I don't want to just say that plug this node everywhere, right? Because sometimes you want to have a double, sometimes you want to have stray. It's really situational, but if you want to use it, it's there. And these are some of the most commonly used nodes in Pixel Composer. I believe that no matter what project you are using, you're gonna have to use some of this node. And this is just a high level detail. I haven't go through like all the property in this node. I think that you should just try and use it, put in the node and try to adjust this property to see what it does and play around with it. Right, and once that you get used to all this basic fundamental stuff, you can now try to go and use more interesting, more weird node that I haven't talked about. But yeah, that will be it for today's video. I hope that it is useful for you. So thank you everyone for watching. Special thanks for all the Patreon supporter, and see you in the next one.